Thank you very much. It's great to be here in the city of opportunity, modern ideas, and success. I'd like to give you a progress report on something that I've been working on, the Seif project. In order to put it in context, we first need to talk about the web. Anyone ever heard of the web, the World Wide Web? Anybody? I'm not surprised that a few hands went up because it's the most important application delivery system in the history of the world. Almost everybody on the planet is on the web. A huge amount of commerce and social interaction and everything is happening on the web. And that's kind of a problem because the web was not designed to do any of the things that it's doing. It was intended to be a simple, even primitive, document retrieval system, a hypertext retrieval system. And we went way, way past that, but we didn't really work it out when we buzzed past the original goals. And so as a result, the web is really difficult to develop for, much more difficult than it should be. And it has some really serious problems. And for me, the worst of those problems deal with security. As we're putting more and more of our lives online, more and more of our wealth, more of our meaning, and the web is capable of betraying us and allowing all of that to be given up. And that's a bad thing. So the history of security in computers really starts with passwords. The very first computers were secured by men with guns, and it was really effective. The first computers were designed for military applications or code breaking, weapon design, that kind of thing. And there were sentries around the machines who made sure that nobody could get access to them who shouldn't have had access to them. And that worked pretty well until the advent of disk drives. When disk drives happened, then there was now a need for security because any program could potentially get to any information that's on the disk drive, information that it might not be entitled to. And it becomes especially a problem when time sharing happens. Time sharing was a service, the first computing as a service in which people would buy a piece of time on a mainframe, and you could have lots of people dialing into the same mainframe using it simultaneously, and passwords were required to make sure that nobody was getting on the mainframe without paying for their time, and also to make sure that they weren't getting access to other accounts that they were not authorized to do. When personal computing is invented, we forgot all of those lessons, and we started over. The first PCs didn't have passwords, and that was fine until they start to get hard drives, and then floppy-based viruses start to go around, and then we start to network them, and then we learned again everything that we had forgotten from the time-sharing era. The first time security seems to be involved in the design of the web is in RFC 1738, which is a document which first describes URLs. And in that document, they describe a format for a URL which contains a password which will be sent over the internet in the clear. And at least one of the authors of that RFC recognized that this was a really bad idea, and he inserted this sentence: "The use of URLs containing passwords that should be secret is clearly unwise," which is an amazing bit of understatement. But that's where the web starts. So in order to look at how we're going to fix the web, we first have to look at what's wrong with the web. Now, many of you are making a living on the web, and you may have never worked in any other environment. The web is all you know. And so I'm going to say things which are going to be shocking and hurtful, which are not directed at you at all, okay? I'm talking about the web. I mean no offense to anybody here or out there. So what's wrong with the web? Well, the first problem is its insecurity, which is because it was not designed to be a secure system. We tried to add security after the fact, and that rarely works. I also have a problem with its complexity. Because it was not intended to be what it turned out to be, we've been patching it and adding stuff without a lot of foresight. We just keep adding more and more stuff. So you get an increasingly big pile of stuff. And given the way web standards work, it's impossible to remove stuff from that pile. So and the pile is full of Swiss cheese holes and other things, and it's not repairable. All we can do is lump more stuff on top of it. W3C does not have the power to reduce that pile. All they can do is make it bigger. So let's look specifically at what's in the web and what's wrong with it. So we'll start with HTTP, the Hypertext Transport Protocol. I see it as being three things. First is it's a data format for expressing key value pairs. That's how you describe a request or a response. And it's a very fussy key value pair format. I think there are much, much better formats for expressing those sorts of things. It's also a negotiation protocol. The first web browsers were very incompetent with respect to image formats, protocols, and so on. And so a image might be requested, and the browser and the server will be in a conversation about, well, I don't know about JPEGs, do you know about GIFs? And they'll do that and try to figure out if they can. And we're still sending that on every request, so we're wasting huge amounts of bandwidth on that. And then it's a request-response protocol. You make a request, you wait, a response comes back, you disconnect, and you're done, which made a lot of sense when the web was just a simple document retrieval system. You get a document, you get it back, you disconnect, then you might click and go to another place. But that's not what web pages look like today, right? You might have hundreds of assets on that page. You've got, you load a script, load another script, some images, another image, style sheet, and so on. You might have hundreds of those, and for each one, you'll request a thing, and you'll wait, and then you can request the next one, and then you wait. And so you can waste an enormous amount of network bandwidth just waiting for this stuff. So to mitigate that, browsers will open up multiple connections to the same server just so they can get a little bit more activity going on the HTTP, but that adds another level of complexity. It's not really a solution. Then there's DNS, the domain name system. This was a well-intentioned thing so that people wouldn't have to remember IP addresses, which is a terrible user experience. That instead you could type in the name of a server and it will connect you to, or tell you what the IP number is so you can connect to it. Unfortunately, it's not compatible with the world's trademark systems, and so there's constant legal bickering, and there's security problems with it, and domain squatting and similar names which can catch people accidentally, and there's DNS poisoning attacks and other things like that. There's SSL, secure socket layers. But the people at Netscape wanted to put commerce onto the web, and they recognized that they needed some way of encrypting the traffic, and so they came up with SSL. Unfortunately, it's really, really complicated, and it's very slow. It requires too many round trips in order to get a connection going on, and it has big security problems. We've been doing SSL for 20 years now, and it seems every month another huge error is found in SSL. It doesn't seem to be converging on something that's correct. It's awful. And one of the things that makes it awful is its dependence on certificate authorities. The most famous of the certificate authorities is VeriSign. So if you get a certificate from VeriSign, that's supposed to prove something, but the only thing it really proves is that somebody gave some money to VeriSign. So I don't know who they are. I don't know why I should trust them, but that's how the thing works. But even worse than that, there are hundreds of other certificate authorities who I know even less about, who I trust less, but your browser trusts them equally. Many of them have already been corrupted. Then there's HTML, the hypertext markup language. Is HTML a good thing or a bad thing? It depends on what you want to do. If what you want to make is simple technical documents that can link to other technical documents, it's really not very good. It's fussy, it's cryptic, it's ugly, it's brittle. That's why we invented markdown languages. Markdown languages do the thing that HTML was intended to do and do it much, much better. Now, if your intention is to deliver interactive applications through the web, it's terrible, because it wasn't designed to do that at all. And we've been struggling with trying to figure out how to make it work. And the state of the art seems to be templating, which I hate templating because, Well, for a lot of reasons. One is it's the XSS attack vector. It is possible to design a templating system which does not expose people to XSS attacks, but apparently it's never happened because the attacks still happen every day. It tends to create terrible architectures because everything in the stack is focused on generating HTML. I've seen it go so crazy that there's HTML templating happening in browsers. I'm not kidding. That stuff's going on. It's crazy. The thing I hate most about templating is it's a trap. Because everything is focused on HTML, we can't ever get rid of it. We can't ever move on to something else because there's HTML dependency going all the way back to the database. You know, how do you correct that stuff? Then there's the DOM, the document object model, which is the API that the browser presents to JavaScript. It is the worst API ever imagined. I'm not telling you anything you don't know, right? It's painful to use. It's at the wrong level of abstraction. It's not specified adequately enough. Portability problems. It's insecure, awful, awful thing. Then there's CSS, crappy style sheets. Okay, so I don't need to tell you what's wrong with CSS. Then finally, there's JavaScript. JavaScript is a hot mess. JavaScript was designed in 10 days, and it turns out you can make a lot of mistakes in 10 days. And yet, there is a little bit of genius in JavaScript. And that's why it should be redeemed. I think JavaScript, because of that little bit of goodness, has unexpectedly become the world's most popular functional programming language. Nobody imagined that ever happening, especially the guy who designed it. Because if you'd known that was the fate, I'm sure he would have done a better job. But if you strip away all of the badness in JavaScript, and there's a huge amount of it, and TC39 is powerless to ever remove it, all they can do is add more crap on top of it, and they're busy doing that for you. But if you work with a well-designed subset of JavaScript, you can write good programs. And so I'm going to keep that piece, but I want to move away from everything else. So I'm proposing coming up with a thing which repairs the web. And I'm not the first to have proposed this. Many have tried this before. Microsoft, Apple, Adobe, Oracle, and many other companies, large and small, saw the problems inherent in the web and thought this is an opportunity. We can capture it or replace it and take over the world. Their technology is always better because they could see what the web got wrong and make stuff right. Most of the solutions that they came up with were by design not open because their goal was to close the web, to capture it, to turn it into a proprietary system. And fortunately, from my point of view, they all failed. And they failed not because their technology wasn't much better than what we have on the web, but because they did not have a suitable transition plan. They did not figure out how to convince everybody in the world to go to their new proprietary platform. So that turns out to be a key part of this. So what I propose is to upgrade the web. I want to keep it doing the things that it does well in place, not changing it at all, but to add a new mode to it which allows us to take advantage of new kinds of applications which give us the security and the ease of development that we need. So there's a brilliant guy named Zuko who has a theory about names. He says that there are three interesting properties that a name could have. It could be human meaningful, it could be securely unique, and it could be globally decentralized. And you can get at most two of these characteristics from any name. And the one that the web chose was human meaningful, at least to the extent where a URL makes sense to humans. But I'm more concerned with security at global scale, and so I'm taking the other two instead. So the new system that I'm proposing is rooted in using 521-bit private or public keys as globally unique identifiers, so that with this new system, we will never again send a password over the network, encrypted or in the clear. Instead, we'll use public key cryptography as it was originally intended in order to secure our applications. So to remind you about how cryptography works, we've got two major techniques. There's the symmetric stuff, which tends to be used for link encryption, where you've got a symmetric key which is used to both encrypt plain text and to decrypt ciphertext. And then we've got the asymmetric stuff, which is the public key stuff, in which you've got two keys. One is used for encrypting and the other is used for decrypting. So in this model, the public key is shared with everybody in the world. Anybody you ever might want to interact with, they should know your public key. That's how they'll know it's you. And the way you prove it's you is that you are the only person in the world in possession of your private key, which means only you can decrypt the messages that they encode for you. Having that, we don't need passwords. So we'll also provide trust management because people cannot manage 521-bit keys and IP addresses. It's just not possible. So we'll provide a way where you can keep knowledge of all the people and organizations you have relations with and keep them out in the cloud in some safe place. And you can give them your own private pet names, which no one else will see, which will allow you to know who each of these guys is. Our computational model is based on a thing called a VAT. A VAT is a computational container. You can put things into it. The things that you put in there can't get out, and they can't communicate with anything else except through JSON communication to specific endpoints. So that allows us to take code from a third party or any party and put it in that thing and allow it to do useful computation for us, but constrain it so that it can't get loose and do bad things. So that having VATs which we can connect together over JSON channels allows us to have a model of computation in which we have cooperation under mutual suspicion, which means we can have many parties working together for the benefit of the user without being able to get over on each other, which will enable lots of new interesting stuff. So we've begun implementing and releasing some of this stuff. The first piece is called Seif Node. It is a module adding cryptographic services to Node.js. It provides elliptic curve 521, which we use for the public keys, AES 256, which we use for link encryption, and SHA-3 256 for hashing. Now, all of these are much stronger than are needed for this application, but I am paranoid, and so I'm using cryptography, which is stronger than we need. That is not in any way a guarantee that we got the security part of this right, but I think it's a necessary precondition. And we especially paid a lot of attention to random numbers because you will generate your own key pair. I don't trust any service to do that for you because it means they will know your private key. And I don't trust them to not hold on to it and may be forced to compromise you later. So, but in order for you to generate your own 520-bit, 521-bit key pair, we have to make sure that you've got really good random numbers, because if the random numbers are of not sufficient quality, then they're going to be collisions, and that's not good. So we're adding an entropy collection module to Seif Node, and it will harvest entropy from the operating system, but I don't trust the operating systems, including operating systems that haven't arrived yet, to give me sufficient entropy to allow us to generate good private keys. So we will also open up your microphone. We'll only do this once when we install the stuff. And we'll listen for a few seconds. We're not paying attention to what's going on. We're just looking for noise. In fact, you don't even need a microphone in there. We just need stuff coming out of the audio converter. And we'll do a similar thing with your camera. We'll turn that on and watch for just a few frames. We're not actually looking at you. In fact, I would highly recommend you get a piece of masking tape and put it over the camera thing on your laptop, because you don't know who's watching. So, and that works fine for us because, again, we're not looking for pictures, we're just looking for noise. And we'll assemble all of that in randomness and use that to generate your private keys. Then we've also just released the Seif protocol. The Seif protocol provides for secure JSON over TCP, and it's an efficient session protocol. So one of the things I like best about the Seif protocol, well, first off, it uses JSON. I like it. But I also really like the way we do our handshake. So Alice and Bob want to make a safe connection. Alice starts knowing her own public key and private key because everybody knows their own pair. And she also knows Bob's public key because that's how she knows Bob. Bob also starts knowing his own public and private key. He does not know who's about to connect to him. He might have had a previous experience with Alice, but he doesn't know that she's about to call. So Alice will generate a random handshake key, a 256-bit session key, which we'll use for the next step. And she will send a message to Bob. The message will be in the form of a JSON message. It will contain a safe property, which tells us what version of the protocol we're running. Today we're at version 1. And this is all of the negotiation that's going to go on about formats. If the server decides Safe 1 is not safe anymore, it'll send back a message saying you need to move up to Safe 2 or Safe 3 and then disconnect. So we intend this to be a very brittle mechanism. The SSL took the other approach that they allow compromised cryptography to remain in play for decades, it turns out, which allows attackers to choose the weakest crypto options available and use those to attack. We're not going to do that. We're going to have a very brittle system. Everybody's going to have to move up within a very small window. Then the next thing in the JSON message is going to be Alice's handshake key encrypted with Bob's public key, so that only Bob will be able to find that. And then Alice will use that handshake key to encrypt her public key. This is for privacy, so nobody can see who is trying to connect to Bob. They can probably guess because they can see Alice's IP address, but we're going to pretend like there's still privacy in the world. There's not, but we're going to pretend. So Bob receives the message, and after decoding it, he now knows the handshake key, and he uses that to obtain Alice's public key. So he now knows who's trying to connect to him. If he's had previous experience with Alice, he can load all of that stuff in. If not, then Alice may be a new customer or someone, and so he'll be prepared for setting up a new account or whatever he's going to do. And now he's going to send a message back. He's going to generate a random session key, which is another 256-bit number, and he's going to send back a message which is encrypted using Alice's handshake key, which will contain the session key encrypted with Alice's public key. When Alice receives this message, she now knows the session key, and she knows that she is connected to Bob. No one else could have sent her the session key except for Bob because he had the private key. That she could not have gotten this stuff if he had not had her H in his private key. So she knows who he is. And when Alice, from now on, all messages will be encrypted with the session key. And when Bob receives the first message from Alice, he will know that it was in fact Alice, and it was in fact Alice who initiated the connection. We established this in one round trip, which is a really nice thing for performance because CPUs have gotten a lot faster, so computation is almost infinite now, and we can expect network bandwidth to improve because the pipes are going to get fatter, but they're not going to get shorter. Moore's law does not apply to the speed of light. And so ultimately, the only way to reduce latency is to reduce round trips. So being able to set this up in one round trip is pretty close to optimal. It's going to be a full duplex protocol. It's not a request response like HTTP. Either party can send a message at any time. You can send as many messages as you want, and either party can initiate. So we can get very different patterns of flow than we get in the current web model. And that will enable new classes of applications, what they used to call push, where if the server has something you need to know, the server doesn't have to wait for you to ask. It can just send it right along. And because we can have all of this stuff going in both directions simultaneously, we also take better advantage of the network bandwidth. We'll provide 3 ways of sending a message. There'll be the normal send, in which you can get a callback, which will tell you if the message got delivered or delivery failed. For example, if you're on a portable device and you lose network connectivity. We'll have a reliable send, which will attempt to send the message, and if it doesn't get there, we'll, again, because of a disconnect perhaps, we will persist it, we'll write it out to storage, and we will then attempt to retry it once the connection is established, maybe in tomorrow or next week. Whenever we can get back to that server, we'll then send that message. So that's reliable. Then there's unreliable send. We need to come up with a better name for this. This is for doing telemetry, where I've got a status message and I want the other party to know this is what's going on right now. And if it gets delayed, we'll just throw it away. That we don't want to end up sending all of the stuff. We just want to send the last one. And all of that's available on GitHub too. Then the next step is we're going to implement Seif resource management, in which we will implement a retrieval system in which we access assets not by name, but by their hash. So we'll take a hash of a resource, and you'll say, I want the thing that corresponds to this 256-bit number and this length, and you'll get that thing. And it's guaranteed you will get that thing and nothing else. And it has some really interesting performance properties because it doesn't matter where we find it. You know, it could come from the world's most evil server, but as long as the hash code matches, it's all right. The next thing we're going to do is Seif apps. So we're going to provide a way of making apps that can run on a desktop or on a mobile device, which will be free of HTML, but will use JavaScript. And will be built on Node.js and Qt. So who knows what Qt is? Okay, great. In the US, nobody has any idea what Qt is. So Qt is a very nice application framework that was developed in Norway. It is very capable, but we're only going to use a tiny part of it, the part that knows how to talk to the screen and to I/O devices and to GPUs. So this is the architecture for Seif app. In Qt, we'll be running UI code. So your application will have a display presence in which it will put stuff on the screen and interact with the user. And we want to make it capable enough, because it's written in JavaScript, we can do this, so that that display presence will work correctly on very small screens, very large screens. So we'll finally get that thing right. And the Qt presence will not have access to the network. It will not have access to the file system. It will only be able to talk to the logic presence that's running in Node. We're going to take Node and we're going to strip it way down too. So we're going to remove almost everything from Node, mainly for security reasons, that we don't have the resources to vet everything that's in Node. There's way too much. So we're just going to leave the event loop and TCP and just a couple other things. We'll take out NPM because it allows you to load anything from anywhere. You don't want that in a secure system. So we're going to get rid of that and replace it with something else. And then that thing will be able to talk to Qt, and it will be able to talk to a server. So everything will be JSON messaging going through that. Our next step will be to take that and bundle it as a helper app so that it can run in a web browser. Now initially, the way it'll work is you will have to download this thing and install it into your web browser. And then anytime you hit a safe URL, then this new thing will pop up. That will work for you, because you all understand how this stuff works. It will not work for most of humanity. So, but it will allow you to get a preview of the Seif system and make a determination, is this something that we think we want to go forward on or not? You'll be able to make an informed decision about that. And then we need to convince everybody else in the world to go along with it as well. So the goal of the Seif project is to provide safe and effective relationship management on the web. And this is the transition plan. So step one, I need to convince one progressive browser maker to integrate the Seif helper app. And it should be an easy thing for them to do, because all they need to do is give us a rectangle and that we can put pixels on, and UI events, and a JSON channel that can talk to the browser. And we will do everything else ourselves. So integration should be really easy. I don't know which browser maker is likely to do this. Pretty confident it's not going to be Apple. And probably not Google. I think most likely Mozilla. Mozilla used to be a technology leader, and they've had recently a tough time keeping up with the bigger companies. This might give them a chance to buy some new market share. Similar thing going on with Microsoft. Microsoft has contributed a lot of technology, good and some not good. Last year they released their Edge browser, which is maybe one of the best things they've ever done, and no one cares. Just they're getting no pickup on that at all. They might want to get on to Seif, because that would, again, be another thing that would help them to get interest. Then I need to convince one secure site to require its customers to use that browser. I need to convince some medical institution or government institution or financial institution, somebody who has a big need for security, who is scared to death about transacting stuff over the web today, who's desperate for a better alternative. I need to convince one of those guys to adopt Seif, and then we'll see what happens. Assuming that goes successfully, risk mitigation will compel other secure sites to do the same thing. It's sort of like penguins. When penguins are standing on the edge of the ice floe, and they've been on the ice for a long time, and they're really hungry, and they want to jump in the water because there are fish in there, but there are also sharks and leopard seals and things in there that eat penguins, and so they're all looking over the edge, and they kind of push closer and closer until finally one of them slips and falls in. And then everybody looks, and if he comes back up, they all go in. So I'm hoping this is going to go like that. Then competitive pressure will move the other browser makers to do this too. They don't want to be the last one who doesn't provide safe interaction on the web. And then I think the whole world will follow. That, because this, I think, this is an unfounded claim. I think we're going to have a much better development model than you get on the web. So I think this should be attractive to you. I have no evidence to support that claim, so we'll just have to see how this unrolls to see if I'm right or not. But, everyone, I think we can convince everyone to go. And nothing breaks. I'm not proposing changing anything about how the current web works. So we'll have two modes of web, old mode and new mode, and they will both work in the same browser. And for most purposes, users will not be able to tell which is which. And I think that's why this transition plan might work, because all of the other transition plans were attempting to capture you as developers, but they completely lost sight of the audience. And the audience is the critical population that we need to move over. So the old web was really good at promiscuity. You could click on something having no idea what it was, where it would go, and you end up in some place, and click on something else and go, and it did that with relatively low danger, and so you could go and discover a lot of stuff. You could surf the web, and that was great. It becomes a problem when you need to be able to go back and be confident that you're actually going back to the party you think you're going back to. It turns out the web does a really poor job of that. That's what the new web is for commitment. That we know who each other are, and I want to make sure that we're doing this and we're not being spied on, and we're not going to be subject to man-in-the-middle attacks or confusion or phishing or any of that stuff. We're going to be able to reliably transact. And that will allow us an internet of people, which I think is even more interesting than an internet of things. So it's difficult to make secure software. Security is really, really hard. You have to make sure that the software does what it should, which is always a struggle, right? But when you're talking about security, you also have to make sure that it doesn't do what it shouldn't. And often it's hard to know what that even means. And so making this stuff is really difficult. And we know that no software is initially secure. And so I'm pretty confident that the first releases we have of our stuff, even though we're trying to be really diligent, someone's going to point out something really embarrassingly stupid that we did. And we'll then, gratefully acknowledge that discovery and try to fix it. And I'm hoping that we will, unlike SSL, converge on something which is good enough. And I believe only a minimal approach can produce software that is eventually secure. And we're designing Seif to be as minimal as we can figure out how to do, but still allow it to be complete enough to make the applications that we imagine. So this is the Seif project, or the Seif project. Part 1 is done on GitHub, the Seif node module for Node.js. Part 2 is done on GitHub. Part 3 is in development now. No forecast on when parts 4 or 5 will be done. They are much more complicated than the first stuff, so it's going to take a while. One of the really great things about the way I've been doing this project is no one has asked me, when's it going to be done? And I haven't volunteered it. I have an idea of when I think it should be done, but I'm not telling anybody. And the reason for that is that I deeply believe that the making of good software takes time. And if you try to make it take less time, it takes more time. And I don't want to be pushed into a situation where we release it quicker than we think we should have to. So we're going to take our time. So much of what I'm talking about is vaporware, and it is extremely irresponsible for me to be coming out in public and talking about vapor in the way that I'm doing. But they invited me to talk and said I could talk about anything I wanted. And this is interesting to me, so this is what I'm talking about. So there's nothing new here. There's no new science, no new technology. This is just a fresh packaging of ideas that have been floating around for decades, just trying to put it in a way which I think will make sense of the web finally. So check us out, the Seif project. Go to seif.place. That'll direct you to GitHub. So be safe. Thank you and good night.
Thank you for your talk. My question is, how do you plan to guarantee security or make claims about the security of Seif as it is hosted in an unsafe environment?
So my biggest fear about this system, your safety does not depend on the safety of a server. Well, or we have no control over that. So if some evil government invades your server farm and shoots all the good people and takes it over, nothing I can do about that, right? That's just the way that goes. I'm more concerned with what happens on the user's own devices. And my biggest concern there is being attacked from beneath. That there's no way that an application can defend itself from a malicious or incompetent operating system. And I think maybe all of our operating systems are at least one of those two things. And so I'm hoping that the operating systems will get their acts together so that that particular attack from beneath is no longer a problem. The other thing I need to figure out, if anybody is working on biometrics, I want a biometric system which is used not just as a password replacement, but I want to know that the user is still in control of the device. So if someone snatches the thing away from you, I want it to shut down. I want it to know enough about you so that it knows that you're no longer in control. So if someone's working on that, I'm not working on that, but I need that. So get on it, whoever you are. Yeah.
Okay, I have a question. Where or how can I get the first public key? Because that sounds like a big problem. So how could I get the public key of Bob?
So that's a good question. So we're going to have a transition device that gets you from the old web to the new web. And this is that device. So you've got a URL. This is the ugliest URL ever designed. It starts off with the word safe. I've been flirting with the idea of changing it to web, say web colon, because it seems really cool and nobody else took it. Yeah. But right, for now, the working title is safe. And then there'll be your 521-bit public key, then an @, and then your 128-bit IP address, and then optionally a referral code after that. And you can get that from a number of places. One is you could get it from Google. You know, if you go and ask for your favorite site, and Google says, we're pretty sure that it's this guy. It's hard to fool Google on this stuff because they work on the big numbers, and it's really hard to fool them. And that page will contain this URL, so when you click on it, it'll put you into safe mode, and it will try to do the handshake to that public key at that IP address. Okay? And there are other ways you could do it too. You could put it on a billboard. People could snap a picture of it and connect to that. We're assuming that it'd be really hard for a miscreant to put a public billboard out there. You know, so anything which is hard for a bad guy to do. Another way it might work is you go to your bank, and your banker will hand you a card with a QR code on it and a secret referral code, and you click that, and that establishes your connection with the bank. So there are lots of ways that you can get the first public key, and then from that point on, it all happens in the safe world.
Okay, so I'm going to ask, I'm here, yeah. I'm going to ask half jokingly, but so you said that current web is a pile of layers of security. SSL is just a protocol for choosing which security is the worst one. But actually you're betting now on asymmetric cryptography, and in Seif there is no way to replace it. So assuming in future we all see asymmetric cryptography stops being enough because of quantum computers or something, is there a way to escape that, or do we have to disable Seif?
No, so you recall that the first thing in the first handshake packet is the safe level. Yeah. So if at some point we determine that elliptic curve is no longer trustworthy, and we figure out what the thing is that is, we don't know what that is yet, but I'm assuming that someone will figure it out by the time we need it, then it might be that safe level 2 is that thing, and then everything migrates forward.
Great, thank you.
Hi. I was wondering in the Qt-based UI solution, are you trying to do anything like with semantic tags or anything to increase searchability, or is the text even discoverable by a search engine?
It's not. So all of this stuff is going to be dark. Search engines cannot see it. Nobody in the world, even NSA, cannot see it unless they can compromise at least one of your public keys. So if you want to have stuff which is discoverable by Google, you're going to have to keep it on the old web. This stuff is going to be, they're going to be blind to this stuff.
Completely disregarding HTTP2, or are you taking ideas from it?
I'm watching it. I think Google did some clever stuff with Speedy. The difficult constraint that they had to live with was they wanted to keep basically the same schema as SSL, and so they're stuck. I mean, there's only so much stuff they can do. They can't do the stuff that we can do because we're doing a clean slate. So I'm glad they're doing it. I wish them luck. And in fact, they will make it easier or safer for people to migrate from the old web to the new web, because we can have the HTTP2 stuff, which is the thing that delivers the safe URL. So I'm glad they're doing that, but it's not sufficient for what I'm trying to do.
Okay, hi, question over here. Oh, am I being rude? Is someone else ahead of me? Okay, oh, well. Just go with it, okay.
I don't know if you're being rude or not.
I'm over here, sorry, down here. Hello, loud shit.
Oh, there you are.
Yeah.
All right.
It sounds like we're doing this in a browser, all right? Now, I have friends who've worked in similar kind of projects for this before, and the conclusion they came to whenever they're working with browsers is that, well, it's really, really hard to trust a browser because we can all install loads of crappy extensions into it, which makes it untrustworthy. And I don't know how you're going to get past that. And maybe you could explain some of that.
Yeah, because we're going to be in our own space. So the only way the browser will talk to us is through a JSON channel. So
Okay.
that's the only way in or out.
Here. I want to ask, because you've mentioned several times that we are working on it. So who's backing that up? Is it like PayPal initiative too, or yeah, some kind of consortium, or?
No, PayPal is very generously supporting this project, and they've been great. They have not asked for any particular concessions. They have not acted evilly in any way. They have not asked to be a privileged site or a phone home source or any of those things. They're just letting us do the work, which is, and they're letting us do the work in open source. So everything we're doing, we're releasing as we do it. So it's all out there. If other people would like to come in and help us on the effort, that would be wonderful. But yeah, I'm very grateful to PayPal for their support of the project.
I have a question. Won't the Seif be affected by a restricted key size policy and effectively shut down by some governments?
I'm not paying any attention to that. That, as an honest programmer, that's all I can do. So I understand that our security is perceived as a threat by many governments. And I'm hoping that because we're doing this in the open, once it gets out there, it's out there. And if the resistance decides we're going to go forward with Seif, there's no way to stop it. There's no singularity in Seif. There's no one point where if we shut that down, the whole thing dies. So we'll see how that goes.
Hello, I have a more practical question. So you say that you take Node and the Qt, and it will be integrated in the browser. And you take a lot from Node, but what about V8? So is it Mozilla, for example, would be okay that you put the V8 inside a Mozilla, or you plan to rewrite on the different JavaScript engines?
Well, we're using Node. Node has V8 built into it. That's already open sourced and licensed, so we're just using something that's already out there.
But, I mean, it means that in browsers there will be kind of two
Well, actually be three, because there's another JavaScript engine in Qt.
Okay.
So,
Thanks.
But, you know, we got lots of memory now, so it's not the way I would have architected it, but that's kind of how it turned out. And I actually feel better having our own JavaScript engine, because it means that if the browsers gets corrupted, that doesn't automatically mean that we got corrupted too. So, and in the scheme of things, the JavaScript engine isn't all that big.
So my question is going to overlap a little with the previous one, but why didn't you, for example, choose to embed some portable bytecode instead of JavaScript? Because that way we could have killed two birds with one stone. Get rid of JavaScript, or maybe are you counting on WebAssembly?
Believe me, I considered that. I'm really looking forward to the day that we put JavaScript down in the cold ground, but I don't think that day has come yet. And for right now, there's a whole lot of momentum, and I have a really steep uphill job to do on this thing, trying to convince everybody in the world to do another of my things. You know, you only get so many chances at that, right? So saying, and a whole new programming language, I think that'd be too much. I don't think I could pull that off. So that's a really good question. What if we did both, added a new language as well as doing JavaScript? So many years ago, as an experiment, Mozilla put Python into Firefox. And integrating that wasn't too hard, but they never exposed it to the world. And the reason they didn't was they had just spent 20 years figuring out how to secure JavaScript. And Python's a great language, but it was never tested that way. And they didn't want to have to start over and be responsible for all the security exploits from having done that. And that is the main reason why JavaScript is going to live at least as long as the web lives. That, earlier today there was discussion about how languages have to grow or die. JavaScript is exempt from that. As long as there's a web, it doesn't matter what JavaScript is, we're stuck with it. So as long as we're stuck with it, I'm going to use it. At the same time, I am hoping that someday we can obsolete it and move on to something much better. I haven't seen that next language yet. I have gone out and appealed to people, design that new language. And from time to time, someone will come up to me and say, oh, it's C#. No, it's not C#. So I'm waiting. Haven't seen the language that is enough better than JavaScript that does the things that JavaScript does well enough to be the next universal language. I'm really hoping someone figures that out.
Yeah, I want a really great presentation. It was super interesting. So one of Roy Fielding's architectural constraints for web-like systems is that uniform interface of the URI, of the URL. Will you keep that? Will internally assets, will they be using URLs? Can you link between the old web and the new web?
You can link you can link both ways. So you could have a URL in a Seif application which will then tell the old browser to display something. And this URL will tell the new browser to display something. That's all. Everything else is different.
Hello. It was a very interesting talk, but I have questions and notes. You say that SSL is like every month new vulnerabilities found, but you're aware it's mostly implementation, not protocol itself. And it's only because it is under strict open, well, not audit, but attention. So how are you going to make sure that your own security is under the same massive attention, so you'll make sure that it's not wrong? That's first question.
Yeah, we're going to do that by making it much simpler. And the code's on GitHub. Check it out. Please tell me if I got it wrong.
I know from the practice that it's really, really hard to find without deep mathematical background any problems in security. And especially if you are combining existing security like you are doing.
Right, so if your argument is we should stay with the thing that we have never gotten to work over 20 years.
No, how do you plan to go for user, basically? Because currently it's not.
And I told you, we're going to do a thing which is much simpler, based on a much simpler model. I think simplicity is the only way to get provable security. And only time will tell if my assumption is correct. At this point, I have no evidence to show that I did get it correct.
Do you plan on some audit certification, something like this?
From who?
That's the question.
I'm open to suggestions.
Okay, then second question.
If you'd like to certify it, I think that'd be swell.
Well, I can try.
Thank you.
Okay, so let's maybe stop here.
Can I ask second question?
Okay.
Last one for me. You tell that you are going to have all these pet names, addresses, public keys, everything that is decentralized. It takes, well, much space for this, especially for a mobile device, for example, where it can be a problem.
Space?
Yes.
On mobile devices?
Yes.
You've got gigabytes of RAM in your pocket.
Not everywhere, and especially if we have something with secure elements inside or something like this. So where you can make it secure.
No, I'm not concerned about that at all.
At the moment, okay.
Thank you very much. Let's give a round of applause to Douglas.